Hello everyone. In the previous lecture, we have studied about AI agents and introduction to them, where I have told that an AI agent is a autonomous program which has been designed to perform a specific task. We are having different types of AI agents. So in this lecture, we are going to do a basic implementation or a demonstration of each of them. The first AI agent or a type of AI agent is simple reflex agent. So a simple reflex agent is an AI agent which is based upon predefined rules or current input. It do not have any other specialty. It just work upon the basic principles. Let us say we are having a thermostat AI agent which will be taking a temperature, current temperature as an input. It has been set to have a desired temperature, and after perceiving a temperature from the environment, this agent is built to take an action. So, what is the action it will take? For example, if the current temperature is less than the desired temperature, so the desired temperature is, let us say, 22, and the current temperature which is sensed by the thermostat is 18. So according to the condition, current temperature is less than the desired temperature, obviously the heater is going to turn on. And in case if the current temperature is 25, which is greater than the desired temperature, so the heater is going to turn off. Therefore, the task of simple reflex agent is just by checking the conditions, checking the rule, and take the action. Now, the next one is model based reflex agents. These agents use internal model to make decisions. Okay, that means they consider past and current states also. Okay, let's say we are having an model based agent, and the state of a room is dirty. Okay, so what this model is going to do? It is going to take the perception, it is going to take the environment information, and in case if the room is dirty, then obviously it needs to clean the room and move ahead. So when we call this model based agent, there are three things to get the perception. That means three inputs are present here: dirty, clean, and dirty. Three states are there. Okay. So if the perception state is dirty, then the model has to take an action, that is to clean the room. If it is clean, then obviously model will automatically move, it will not take an action. Okay, so here the model is based upon the past and the current states. Okay, and accordingly it will take an action. So this is model based agent. The next agent is goal based agent. Well, the goal based agent, as the name itself suggests, that this agent has to achieve a specific goal, a desired result, and accordingly it has to make an decision. Okay, so this can involve in planning also, and here search algorithms can also be used. Okay, so let us say we are having a method defined as goal based agent, where we are having the current position and the goal position. So ultimately here the task will be to reach to the goal position from the current position. Now, let us say current is 2 and the goal is 5, and we are defining a loop here where you are going to give the current and the goal value in the action. Fine. So the current will start from 2, and if the current is less than goal, which is obviously 5, you have to move right. Okay, so the action is move right. If the action is move right, you need to update the current value. Here, current will become 3 now. Okay, then what will happen? Again, the loop is not over. The loop will update. Current is still less than the goal position. Move right action will be taken again, and current will be updated again. And this process will be continued till your goal is not reached. Okay. So once the goal is reached, then if there is an update, let us say the current position is greater than the goal position, then I need to move left. Okay, that is, I need to do the decrement and the last stages to stay. Okay, so this is goal based agent. The next one is utility based agent. Well, utility based agents, they are used to optimize the decisions in order to make a maximization of the accuracy or performance. Okay, that means here the AI agent will take a decision in order to achieve the highest satisfaction, good score. Okay, let us say you are having a method defined as utility based agent. You are having three options available. Clean, the score is 10, move, the score is 5, and the rest score is 2. So the best action will be having the highest score. Okay. Now these three options are available, clean, move, and the rest. We are going to call the utility based agent, and according to the values which are assigned to these, action will be taken. So highest value is of clean 10. So action will be taken to perform cleaning operation. Okay, fine. So all the AI agents demonstrations which we have seen so far, like these, like simple reflex agent, only rules, model based, it consider past and the current state, then goal based in order to achieve something specific. Okay, so it do take actions according to it, and utility, that means the maximum score or the maximum satisfaction will be considered as a decision or action to be taken. Next one is learning agent. Well, learning agent are the agents which are based upon reinforcement learning. As I told in the previous tutorial also, that these agents do capture the information from the environment as usually been done. Then they do take an action based upon a decision, and if there is something wrong, they learn from it. Okay, so here we are having a simple demonstration of it that is actually based upon Q learning or the reinforcement learning, where I'm having a Q table, and two states are available, state 1 and the state 2. In each states I am having the values like left and the right initially assigned to zeros. Okay, I'm having a learning rate of this agent by zero point 0.1. Discount factor or the reward which is need to be given here is 0.9. Epsilon is the probability given as zero point 0.1. Okay, so like here the learning agent starts its work If the value random selected is less than the epsilon, it's a random value. If it is less than the epsilon, so AI agent will take any of the choice, left or right. And accordingly, the one which is maximum out of it will be returned. So let us suppose we start from a state one, and here learning agent will explore. It will take an action. Okay. So like states, we are having the states that is one at the moment. And when this learning agent is called here with respect to the state one, a random value has been selected. And in case if the random value, if the action taken is right, okay, so the reward 10 will be given. Else the penalty will be assigned of -5. Next state after the operation done here by the AI agent, it will switch to the state number 2 and then Q table is updated. And the update of the Q table is based upon the previous state into here you can see we are going to take a previous state values multiply the discount factor multiplication will be done, the reward will be added. Okay, and then there is a subtraction of the previous state also. So this is the update state, update formula for the reinforcement learning or the Q learning. Here you are going to get a new Q table. Okay, this is your AI agent, which is based upon learning. Your next AI agent, it's actually a multi-agent system. So far, we are working on single AI agent, and now this is multi-agent system. In multi-agents, there are multiple agents who are working in a collaboration or in the interaction also to achieve goals, not only a single goal. Here you are having different goals. So all these agents are helping each other to furnish a goal. They to interact with each other also working in collaboration. So like here is the basic implementation of it. Let us say I am having a message board and there will be some message which I need to convey with the help of an agent, one agent to another agent. Okay, so I need to post the messages. Fine, there will be a sender. There is a content present in a message, and we need to read the messages also. Fine. So there is a class agent where I will be having a name, agent name, the message, and the agent is running. Okay, fine. So if the agent is running, it's going to read the message from the message board and it has to convey that message to the another agent, but do not have to convey to the same. Okay, the agent will not send message to itself. It will send a message to another agent. Okay, fine. So process message, this method will run. This is the process message. Okay, here it is. There is a sender agent and there is a content in the message. Okay, fine. So it need to convey it. Action, that is the decide action. Here is the decide action. So it's our analyzing the data, requesting resources, sharing results. These are the actions which needs to be taken by the agent on the basis of message. Okay, and the choice are random. Any of the action can be taken. It's just a random choice. Okay, fine. And then after this particular task, there will be unit 3 of time interval. There will be a pause. Okay, here is your the main function. Message board is been present here. So, with respect to it, the agents, three agents are being present. They are going to take the message from the message board, and agent will start its operation. There will be different threads will be created for each and every agent, and they are going to convey the message to the other agent, and they will take a sleep of some amount of time. Okay, the entire process will be working for for 10 units. Okay, all these three agents for 10 units, the entire process is going to work. Later on, the agent will stop, and the entire process, the entire stuff will be joined. This is multi-agent system. After this, the tasks which are mentioned, they are done by these agents. Okay, fine. So if I run this code, you can see how it's working. Agent 1 is requesting for a resource, agent 2 received from the agent 1, agent 1 is requesting resource, agent 2 is requesting resources. So, these are random tasks. As mentioned in the code also, that what action needs to be taken, that is random in nature. Okay, fine. So all these threads are working, agents are working, any of the random operation, decision, action they want to take, they can take up to 10 units, up to 10 sleep we have mentioned here. There will be termination. Okay, multi-agent terminated. Fine. Okay. So this is how multiple agents can work together. Okay, here you can see the tasks which we have mentioned, these agents are working on it. Okay, so that's all for this tutorial. We have seen the basics of the different types of agent, demonstration codes, how they do work. And in the upcoming lectures, we are going to discuss more upon agentic AI and the AI agents. Till then, thank you very much for watching. Kindly do like and subscribe to the channel.